All right, so here we've got the notes for section 3.3, rules for differentiation. So this section deals with all the shortcuts, so we don't have to keep taking limits over and over and over again. So we have derivatives of a constant function, so that's derivatives of a number. So df dx or ddx of c, where c is some number, is always 0. So the derivative of number, always 0. F prime of 2, 0. F prime of 7, or sorry, if f of x is 2, f prime is 0. If f of x is 7, f prime is 0. Because remember, the derivative measures the slope. And if I have this equation, f of x equals 2, that's the same thing as y equals 2. That's a horizontal line, and the slope of a horizontal line is 0 for any horizontal line. So that's why the derivative of any number is always 0, because that number is graphing a horizontal line. The power rule, so if n is a positive integer, then the derivative of x to any power looks like this. So mathematically, an example, if you have x squared, so in this case, n is 2, so f prime of x, the exponent becomes the coefficient, and then I take 1 from the exponent, so this would just become 2x to the first, which is just 2x. So you want to do x to the fourth, so the exponent comes out front. I do 4 minus 1 as my exponent, so 4x cubed would be my derivative. So the rule is exponent moves out front, take 1 out, subtract 1 from the exponent. Now if there's already a coefficient out here, it would multiply, which is what the constant multiple rule is. So if u is a differentiable function of x and c is a constant, then you can essentially factor it out first, but it's easier to think about it. So that would be saying, like, say I had 2x squared. So what you would do is you do 2 and then do the derivative of x squared, which if we look up above was this. So this becomes 2 times 2x, which is just 4x. So essentially what happens is if there's already a coefficient out front, the exponent multiplies the coefficient, and then you count down by 1 just like you would before. So 2 times 2. Exponent times original coefficient, so on and so forth. The sum of difference rule just says that you can treat each term separately. It's like you don't have to work the whole problem at once. You can just work pieces. So work the first term, take its derivative. Work the second term, take its derivative, so on and so forth. So if this one wants us to find p prime, the derivative of p, given this equation. So these are each individually power rules. So for t cubed, exponent comes out front, subtract 1 from the exponent. For 6t squared, when the exponent comes out front, multiplies the 6, giving me 12. T, exponent counts down by 1, I just have t. So here, this one has an exponent of 1, so 1 times negative 5/3, negative 5/3. Now in this case, there are no t's left. Technically it's t to the 0th power, but that's 1, so it disappears. And then 16 is a number, so its derivative is 0, so it's gone. So this equation is a derivative of that equation, or is dp dt. Okay, so example 2, does the curve have any horizontal tangents? If so, where? So horizontal tangents occur when the slope is 0. So the first thing I need to do is find the derivative of this. So y prime is 4x cubed, exponent out front, count down by 1, minus 4x, exponent multiplies out front, count down by 1. So that's my equation. I'm going to set it equal to 0. So this is factorable. I can take a 4x out, which leaves me x squared minus 1. Now this is also factorable. X squared minus 1 is a difference of squares. So this would be the full factoring of 4x cubed minus 4x. So where is this equal to 0? Well, it's equal to 0 in 3 places. 4 times what number is 0? So 0. X minus 1, where is that 0? At 1. And what number plus 1 is 0? Negative 1. So this graph has 3 horizontal tangents at x equals 0, x equals 1, x equals negative 1. Okay, so 3, the graph, this thing has 3 horizontal tangents. Where do they occur? So same thing. So I need to find y prime. So that's 0.8x cubed minus 2.1x squared minus 4x plus 5. So exponent times coefficient, count down by 1. Exponent times coefficient, count down by 1, so on and so forth. Now I particularly don't want to solve that by hand, so I'm going to let my calculator handle it. Where is the equation solver? Right there. This is a polynomial of degree 3. So my coefficients are 0.8x cubed, negative 2.1x squared, negative 4x, and 5. Solve. So there are my values. So at x is about 3.54, x is about 0.95, and x is approximately negative 1.86, where the horizontal tangents are. Or you could have graphed this equation and found the x-intercepts, which would be these values here. Okay, so product rule. This occurs if you have two quantities being multiplied together. So remember, u and v are representing expressions like x plus 1, 7 squared, or 7x squared, things like that. So the rule here is, so if the derivative of u times v is you leave the first alone and multiply by the derivative of the second, plus leave the second alone, multiply by the derivative of the first. So here, this guy is my u, this guy is my v. So the derivative of this, so the derivative, so it's u, so x squared plus 1, times dv, that's the derivative of this. So this derivative is 3x squared. Exponent out front, count down, derivative of any number is 0. Then plus, that plus sign is that plus sign, v, so that's x cubed plus 3, times du, which is the derivative of this guy, which is just 2x. Exponent out front, so on and so forth. So this is 3x to the 4th plus 3x squared, if I multiply. This one is plus 2x to the 4th plus 6x, distribute, and then like terms be 5x to the 4th plus 3x squared plus 6x. So that is f prime. Now you could have worked this out the long way. If I did the FOIL up here, I'd get x to the 5th plus 3x squared plus x cubed plus 3. So this string here is the FOIL for that. And if I take the derivative, 5x to the 4th plus 6x plus 3x squared, the 3 disappears because this derivative is 0. So you notice, same thing. So for a 2 by 2, it's not terribly bad just to work the FOIL out and do regular power rules. But if this was like a 4 by a 4 or a 5 by a 5, it's going to take you a long time to FOIL it. Okay, so next we got the quotient rule. So u over v. So this is, you leave, so v is the denominator, u is the numerator. So it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. So here, in this one, that's my u, that's my v. So it's v, x squared plus 1, times the derivative of u, which is 2x, minus u, which is x squared minus 1, times the derivative of v, which is 2x, all over v squared, which is x squared plus 1 squared. So this is 2x cubed plus 2x, that's multiplying that out, minus 2x cubed plus 2x, because double negative will make that positive, all over x squared plus 1 squared. So the 2x cubes cancel, so I have 4x over that. So there's my f prime. Alrighty, 6, so let y equal uv be the product, the two functions u and v, find y prime of 2 if all of this is true. So y prime, so this is a product rule, so it is, let me make sure I get it right here, u times dv, so u, so instead of dv we'll do v prime, plus v times u prime. If I didn't substitute anything in, you just leave the first alone, derivative the second, and then I'm just going to plug my values in. So I'm talking about y prime of 2, that's going to be u of 2 times v prime of 2 plus v of 2 times u prime of 2. And I know all of those values. So u prime of 2 is 3, v prime of 2 is 2, v of 2 is 1, and u prime of 2 is negative 4. So this is 6 plus negative 4, which is 2. The fact that that's 2 and that 2 is just a coincidence. It doesn't actually always work that way. Okay, negative integer powers. So actually it says this works the same way. So if I had x to the negative third, this is the same thing, or sorry, if this is f of x, the power rule still holds. So exponent comes out front. Now the one thing you have to be careful of is if you subtract 1 from the exponent, it becomes negative 4. It's already negative, so when you subtract 1, it becomes more negative. All right, so 7, find an equation for the line tangent to the curve this at the point that, support change graphically. So I can do this a couple ways. I can run a quotient rule on this, or I can write it in terms of negative exponents. I'm actually going to rewrite this. Since they have a single term in the denominator, I can split this into 2 fractions, so it would look like this, which is equivalent to, this guy simplifies to x over 2, and then this. And I'm going to rewrite these as fractions. So x over 2, dividing something by 2 is the same thing as taking half of it, so that's half x. And this, since the x is on the bottom, it looks like that. So that's y. So I need y prime, because m is equal to y prime. So the derivative of this, so this one has an exponent of 1. 1 times 1/2 is 1/2, and the x disappears because it counts down to x to the 0th. Here, it'd be minus 3/2 x to the negative 2. So my coordinate is 1, 2. So I need to find the slope at the point 1, 2, which means I need to plug 1 in for my x value. So y prime of 1 is 1/2 minus 3/2, 1 to negative 2 power. 1 raised to anything is 1. So this is 1/2 minus 3/2, which is negative 1. So to write the equation of a tangent line, I need the point slope form. Y equals m, x minus x1 plus y1. So y equals, so my m is negative 1, x minus the x value, 1, plus the y value, 2. So this is negative x plus 1 plus 2, negative x plus 3. So this equation is tangent to that curve at that point. So if we graph them, so we'll graph the original equation, whoops. So that is x squared plus 3, so that's my numerator, divided by 2x, parentheses around both the numerator and the denominator, and then my equation is negative x plus 3, draw. So if you zoom in here, so you notice there's my curve, there's my tangent line, and it should actually touch. If I find my intersection point, I should get the point 1, 2. So right there, 1, 2, which is the point, because the tangent line touches the curve at that point. Okay, second, higher order derivatives. So when you take y prime, that's the first derivative, but you can keep chaining this process over and over again. You take the derivative of the derivative, that's the second derivative. You take the derivative again, that's the third derivative. And you can keep going essentially until you run out of terms. Now for a simple polynomial, these will eventually become 0, because eventually you get down to just numbers are left and then it becomes 0. But if you have negative exponents or trig functions, this process can potentially go on forever. So for 8 here, it says find the first 4 derivatives of this. So y prime is the first derivative. So exponent out front, count down by 1, exponent out front, count down by 1. So that's the first derivative. So the second derivative, I just take the derivative again. So exponent out front, count down by 1, exponent out front, count down by 1. So if you notice the 2 disappeared here, because the derivative of any number is 0. Here the x disappeared because this was x to the first, but now it's x to the 0th, which means it's gone. So the third derivative would just be 6, because 1 times 6 is 6, the x disappears, that's a number, so it's gone. Then once you get to the fourth derivative, you stop doing hash marks, so it's just a 4 in parentheses, and that's 0. And actually any derivative after this one is also 0, because 0 is a number, so its derivative is also 0. So the fifth derivative is 0, sixth derivative is 0, seventh, so on and so forth forever. Okay, Last example here, an orange tree farmer currently has 200 trees, yielding an average of 15 bushels of oranges per tree. She's expanding her farm at a rate of 15 trees per year while improving her husbandry, her average annual yield by 1.2 bushels per year. What is the current rate of increase for annual production? So her production is equal to the number of trees she has times the number of bushels each tree makes. So the derivative is a rate, so I need P prime. So that's going to be T times B prime plus B times T prime, because that's a product rule. It's two things being multiplied together. So product rule is leave the first alone, multiplied by the derivative of the second, plus blah, blah, blah. I just need to fill in my values. So T is the number of trees she has. She currently has 200 trees. B prime is how many bushels she's increasing. It's a rate change, so that's the 1.2. Primes are always rates, something per something. So B is the current number of bushels, 15. T prime is how many trees she's increasing by, which is 15. And then this all just can go in your calculator. 200 times 1.2, so this is 240 plus 225. So her production is increasing at a rate of 465 bushels per orange per year. So that is your solution. That brings the end of section 3.